Alright, so starting this off, we're looking at solving for x. So in 3 of these problems, x is in the exact same spot. For problem 3, x is on the other side. But what we're looking at here is this. How do we solve for x? Well, in these situations, for 1, 2, and 4, we use the reciprocal power. 729 to 2/3. Third root is 9. Squared is 81. Alright, so we use that reciprocal power to solve. Same thing over here. What's our reciprocal power? Negative 5 over 3. Negative 5 over 3. Well, x equals 1 over 27 to the 5/3. 1 over 3/3. 1 over 243. Now for problem 3, x is standing alone, so really we're just doing the math on that right side. The third root of 125 over 27 is 5/3 to the 4th, which gives us 625 over 81. Last one, similar idea, reciprocal power, negative 4 over 5. Know what? Negative exponent, flip it. Raised to the 4/5, which in this situation gives us, actually, wait a second. I think I got a little trick here to make my life easier. Yeah, oops. So in this situation, note, I should have simplified right away. So if I simplify the inside, I got 32 to the 4/5. 1024 divided by 32 is 32. That makes my life a lot nicer. All right, so I take the 5th root, I got 2 to the 4th, I get 16. All right, so in these situations, x was what's called our base. For here, x was our answer. Now what we're looking at today is, what do you do when x is the exponent? So for these basic examples, a lot of us can just figure it out. But kind of talking through this, here's what we have. All right, so for the problems we're just looking at, all but problem 3, the exponential equation is x is said to be raised to the unknown. Oops, I read ahead. For all the do now problems, the base of the exponential equation is x, and that was our unknown. So what we did for those problems, all but problem 3, is we raised the reciprocal power. Now what we're changing up here is the exponent is going to be the unknown. So what do we do in these situations? So the fact is, we want to find a common base and set the exponents equal to each other. Now one thing that's really going to help us out is that when we're using that table, right? So we've seen the table. Look at the rows. The rows on the table will show you numbers that have the same base. You're going across 2 squared, 2 to the 3rd, 2 to the 4th, 2 to the 5th, 2 to the 6th, so on. That row is showing you all the numbers that give you the same bases. So if we look at our base examples, you look at that table, you see 5 to the x, 5 to the 4th. Right, there's nothing too crazy here. Some of us might just know the answer to that problem. Same thing with problem 2. But the issue with problem 2, a lot of people tell me this. 3 to the x equals 9 squared. That's not wrong, but know what? We need the exact same base. So 9 squared's okay, but know what? We can write it as 3 to the 4th, and that's our great answer. Problem 3. 3 to the x equals 1 over 3 to the 3rd. Another good setup, they both have 3's, but one's a fraction, one's not. We can't have one being a fraction, one not being a fraction. So what can we do to make this not a fraction? Negative exponent. So now we have a 3 to the x, a 3 to the negative 3rd, x equals negative 3, exactly what we want. Right. Problem 4. Right. Problem 4 brings in a little bit of a different idea here. Right. We can't write this as 8 to the x and 8 squared. That's not going to work. Right, so this is where we really want to look at the exponent chart and look in the rows and find 16 and 8. Well, if you scroll across each row, you will find in the row of 2 that 16 is 2 to the 4th and 8 is 2 to the 3rd. Raised to the x power. So our power to a power rule, we multiply. 2 to the 4th equals 2 to the 3x. And then we could set 4 equals 3x and x equals 4/3. And with all of these problems, you can take a moment and you can check. If you check every single problem, you will know for sure that your answers mathematically make sense. Right? Every one of these problems checks out. It's a great feeling. You know that your answer is right. It's nothing, nothing better than that when you're taking some sort of exam. All right, so the key thing here is that we are changing the bases. So let's knock out a few problems here. So again, I'm looking at my row. I see 25. I see 625. That's telling me 5 squared to the x equals 5 to the 4th. 5 to the 2x equals 5 to the 4th. 2x equals 4, x equals 2. No, I messed up. No, that's right, my bad. Let's see, I don't have the table exactly in front of me. Yeah, x equals 2. So, you take a moment, you plug in, you check, it does work. All right, 2 to the x. Don't make that common mistake. People say, oh, it's squared, it's a great one. No, better option. Look at that table. 2 to the x equals 2 to the 6. X equals 6. We plug in, we check, it makes sense. All right, time to get a little bit more complicated here. Looking across my table, 32 and 16, we're in the 2's now. 2 to the 5th, to the x minus 1, 2 to the, I don't know why I wrote that so big, 2 to the 4th, to 3x minus 2. Power to a power rule. So we're going to multiply 5 times x minus 1. And we're going to multiply 4 times 3x minus 2. Now we got the bases of 2. Set the exponents equal. 5x minus 8. 12x minus 8. Oop, that should be 5x minus 5. 12x minus 8. So if I add that over, I got 3. I subtract that 7. X equals 3 over 7. Now, you plug that in, it's going to work. It may not give you a nice, clean exponent number, but hey, as long as you get the same number, that is fine. Right, so it might be weird when you check it, but as they get the same thing, you are good to go. Problem 4. 2 to the x squared equals 2 to the negative 4. X squared equals negative 4. X equals positive negative rad negative 4. X equals positive negative 2i. Weird answer. Right? Weird answer. But you know what? If we take the time to check, this does work. So if I plug in 2 to the 2i squared, this gives me This gives me 2 to the 4i squared, 2 to the 4 times negative 1, 2 to the negative 4th, which is 1 over 16. It does work. They both work. It's just a little strange to get those I values. All right, 5 and 6. Looking at that 5 row. 5 squared to the x plus 2. 5 to the 3rd. 3x plus 4. 2x plus 4 equals 9x plus 12. Minus 12, negative 8 equals 7x. X equals negative 8 over 7. Ugly, gross, but you know what? Works, all good. All right, this is pretty obvious which row we're looking at. We got that 10 row. 10 to the 3rd to negative x plus 2. 10 squared to 2x plus 3. Negative 3x plus 6 equals 4x plus 6. All right, 6's are gone. We're left with x equals nothing. And that works. You got 1,000 squared equals 100 to the 3rd. That mathematically makes sense. Every single one of these problems you could check and you will know for sure that your answer is exactly the same. Alright, taking things up a level here. Alright, we got the fraction. Alright, so, you know what? I'm going to make this 2 to the negative 1 to the x minus 1 to the 5th to the 2x plus 1. Negative x plus 1 equals 10x plus 5. This gives me, subtract, negative 4 equals 11x. X equals negative 4 over 11. We plug in, we check, it does work. Alright, 2. Got this fraction here. Now, my key thing with fraction problems is, with the whole idea of the same base, the fractions must be exactly the same. You can't have 2/3 and 3 over 2. They got the same numbers, but they have to be exactly the same. And with this, you need to have the exact same exponent on both the numerator and denominator. Alright, so for something like this, you can look at this and say 2 to the 4th over 7 squared. No, we got to have the exact same exponent. So we got to write this as 4 squared over 7 squared to the x plus 3. That means over there we got to have 7 and 4. Well, we got 7 to the 3rd and 4 to the 3rd to the 2x plus 1. So we got the same exponents on each side. Both got 2, both got 3, but one's flipped. So what do? We got to get negative exponents involved. 7 to the negative 2, 4 to the negative 2, to the x plus 3 equals 7 to the 3rd, 4 to the 3rd, to 2x plus 1. Now we got what we want. We have the exact same fraction, 7 over 4. On the left side, they both have a negative 2 exponent. On the right side, they both have a 3. So power to a power. Negative 2x minus 6 equals 6x plus 3 minus 3. Negative 9 equals 8x. X equals negative 9 over 8. We plug in and we check, it works. Problem 3. Here's an issue that happens with some people. So we're looking at our chart and we don't see 12 and 17, 28 on the same row. So when in doubt, can you write 12 differently? No way. 12 can't be written differently. So then we just try things. 12 squared, 12 to the 3rd, 12 to the 4th, 12 to the 5th, and so on. Well, in this situation, 1728 is the same thing as 12 to the 3rd. So if it's not on your chart, just try something. Right? 12 is not changing. The other side can change. So just kind of wing it. Alright. Last one here. Looking at what we were looking at before. So I got 2 to the 3rd, 3 to the 3rd to the x equals 3 over 2. Upside down. Flip it. 3 to negative 3, 2 to negative 3, 3 over 2. To the x. Now, what's the exponent of 3 over 2? Can't forget, it's raised to a first power. So this gives me negative 3x equals 1, x equals negative 1/3. And we plug in, we check, and they all work. Take the time to check. Great feeling knowing your answers are right or wrong. Alright, combination here, the hardest ones we got. Using our exponent rules. So I got 3 to the x plus 1 equals 9. Well, right away, 9's 3 squared. Now they're all 3's. But what happens on this side? The key thing we have to remember is that when we are multiplying with exponents, we add. So we have x plus 1 equals 3 squared. 3 to the 2x plus 1 equals 3 squared. 2x plus 1 equals 2. 2x equals 1. X equals 1 over 2. We plug in, we check. It does work. It's amazing. Alright, last problem. 16. I know. 4 squared is good. 2 to the 4th is better. So one thing I do when I have division problems, I write it like this. I find that the biggest mistake with division problems is that people just start canceling things. division with the same base means we subtract the exponents. So we have this, whereas a lot of people just start canceling 2's and telling me like x minus 1 over 3 minus 4x equals something. No way, no way, not going that route. Alright, so going back to the way we were going, we distribute our exponent, we distribute our negative, we got x minus 1 minus 3 plus 4x equals 2 to the fourth. 2 raised to the 5x minus 4 equals 2 to the fourth. 5x minus 4 equals 4. 5x equals 8. X equals 8 over 5. We plug in, we check, it mathematically makes sense. Alright, people. Hope this video was helpful. If you got questions, reach out.